So, hi everybody. I'm Brian Lin, and I'm going to give a quick overview of HTCondor-CE 5, and then I will hand it off to TJ, who will go into depth of the headlining feature of Condor-CE 5, a new job router configuration syntax called job router transforms. Next slide, please. So HTCondor-CE, CE stands for Compute Entry Point. And I won't go into all of the details here, but it is a special configuration of HTCondor-CE or HTCondor. And there was an overview talk in the Autumn HTCondor workshop that you should check out or watch the YouTube video on our channel. Next slide, please. But to give everybody some context, HTCondor-CE is or can be a critical service in a distributed high throughput computing environment. And it is one of the many services that can be run or that should be run. And so on the left-hand side, you may have a user community that has login access to an HTCondor access point. And then you have some infrastructure that is run by, say, the OSG that we call a resource allocation request factory. So for those of you that have been in the business for a long time, you may be more familiar with the terms pilot job or gliding job. And then on the right, the resources may be made available through many different sites who have their own local batch systems. And then the compute entry point is what is used to translate things to that local batch system. Next slide, please. So in this model, the users in your communities submit their work to the Condor SCED, their access point. Next slide. Next slide, please. And then on behalf of those users, the factory will submit resource allocation requests to the CE. And this will be basically the size of the resources that the community needs to support all of the work that has been submitted to the access point. The CE will then take those allocation requests and then submit them to the local batch system, taking into account any sort of local policies, specific partitions or accounting groups that these jobs or these allocation requests should go into. And then the local batch system will start running these jobs on their worker nodes. And the neat thing about the allocation requests is that they will start up some Condor start Ds. Next slide, please. And then these start Ds report back to the Condor or the community's central manager, and then are made available to the access point where all the usual matchmaking is involved, and then the jobs start running under these start Ds. So this is a way to basically make a virtual Condor pool across all sorts of potentially geographically distributed resources. Next slide, please. So Condor-CE 5 is the new major version available alongside Condor 9.0 and the 9.1 series. The 9.1 series is the development series for the HTCondor team. And potentially at some point, we may release a Condor-CE 6 that also has some major changes that would go alongside that series. In Condor-CE 5, we added support for the improved job router configuration syntax. The old syntax is still supported, but we hope that you guys will try out the new job router transforms. The Condor map file formatting has changed, and the location has changed. So for you CE administrators, it's important to look out for this during your updates. This next bullet is hopefully going to be transparent to all of you. We moved to Python 3, and alongside it, we added support for Enterprise Linux 8 based operating systems. And then one other change that may require some manual configuration updates on your end if you need this feature, but we do not set the home environment variable in the allocation request or the pilot jobs environment by default anymore. We do have detailed upgrade instructions and release notes, and they're all available in a redesigned documentation area for Condor-CE. That should be HTCondor-CE.org. Or you can go directly to this GitHub Pages link that will bring you to the release notes and the upgrade instructions. Next slide, please. So going into a little bit of detail about the new mapping configuration, CE administrators should now place their own incoming allocation request credentials to local user mappings in a dedicated directory at CHTCondor-CE mapfiles.d. This works very much like config.d directories that I'm sure all of you are familiar with. When doing this update, your configuration changes to the Condor map file will be moved to Condor mapfile.rpm save. And any of these customizations should then be moved into the mapfiles.d folder. We did the split because we also included a Condor-CE mapfiles.d in user share. And this is owned by potentially, or this is for files owned potentially by downstream packagers. So for example, in the OSG, we provide default SciTokens mappings for the OSG and Glow VOs. And then there are also some default mappings that are required there for functioning of the Condor-CE. We also changed the syntax in these map files. The credential matching strings should be converted to regular expressions. So in the old syntax, a mapping based on the SciToken issuer has 3 fields. The first field is the Condor authentication method to be used. The second field is what Condor maps, or what Condor sees from the credential. In this case, it's the token issuer. And then the third field is the local user that the issuer or the token is mapped to. So in the new syntax, that second field should be converted to a regular expression. And you'll notice that actually for the tokens, there kind of is a comma before that last slash. And that's because when tokens come in, Condor can see both the token issuer and the token subject. So in that last bullet, we are mapping all tokens from that same OSG Connect SciTokens issuer, but only if they have the testing token subject. Next slide, and I think this is where we hand off to TJ, who will sell you on how great the new job router transform syntax is.
All right, so we're going to talk about the new configuration for the job router, and of course the CE is essentially a special predefined configuration for the job router, along with a bunch of other scripts and config. So the reason we changed the job router config was essentially that we had 2 different transform languages in Condor. That was the one used by the SCHTC's submit transforms and the one used by the job router. And the SCHTC's submit transform language is just more powerful. And so we ported that into the job router. And while we were doing that, we also improved the way the configuration for the job router works in other ways as well. Now we're still backward compatible. If you have an old style job router config, it will work the same way it did before. You can also use the new configuration for individual routes. So you can deploy improved configuration one route at a time if you wish. If you have routes in the old config and the new config with a name conflict, then we'll just ignore the one in the old config. So quick review of what the old config looks like. There are basically two knobs. There's job router defaults, which for the CE is where most of the CE boilerplate lives. That is stuff that is common to all routes. Then job router entries is a list of class adds, each one of which is a route. And the way this actually works is we load job router entries, we split it into individual class adds, we merge each of those class adds with the entirety of job router defaults, and that becomes your effective route add. The new config splits these things up, so it's much better to, or much easier to compose your transforms using a bunch of individual configuration steps. There's still one config, I'm sorry, there is now a separate config knob for each route. And the job of the job router defaults is now taken up by two lists. There's a list of pre-route transforms and a list of post-route transforms that are applied whenever we apply a route. The new config knobs, we have a list of names. This is just the names of the routes, and that tells us which job router route knobs to load. Each of those will have a single route in it. And then we have two lists for the pre and post route transforms, and those will be referring to the knob's job router transform name. So now a route is a sequence. And the way this works is when we decide to route a job, we walk through the list of route names one at a time, comparing the job to the requirements expression on the route. And the first time we find a match, and that route has not yet hit its limit for the number of jobs that it can accept, then we do the transforms. We start by creating a variable set for temporary variables. Then we apply all the pre-route transforms. Then we apply the route transform. Then we apply all the post-route transforms. And then we take that modified job class add and we send it to the destination schedule. And then we clear the temporary variable set. So the implication here is you can share variables between transforms. You can set a variable in one of the pre-route transforms and then use it in the route, or consequently, or you can set a variable in the route and pick it up in a post-route transform and do something useful with it. And this is essentially how we handle a lot of the defaulting behavior. The transform language consists of commands, essentially. The commands are, by convention at least, are all uppercase and precede the lines that define the transform steps. There are 6 commands that modify the job: set and eval set. You may be familiar with from the old transform language. They work essentially the same. Default is like set, except it does nothing if the job already has a value for that attribute. And then rename, copy, and delete are used to rename attributes and copy attributes and delete them in the job. They have the nice improvement that they can be regex based. So you can say rename every attribute that ends in test to a new attribute that ends in test2 or whatever. There are also commands that configure the route. These are looked at when the route is loaded. Requirements and universe, the one you'll want to use. The name you probably don't want to, it's there for completeness, but the name of the route is typically the name of the knob. And you don't really want to give it a different name in the route unless you set that to the same value, or things get a little confusing. Then there's also a special command to do evaluation, but to set the result into a temp variable rather than polluting the job add with that Routes are, the syntax of the routes are similar to the syntax of submit. As a matter of fact, it uses the same bit of code that loads submit files, but with some specialization for handling the lines that don't look like variable equals value. Because it uses that same parser, we can use the same kinds of things that we can do in submit files. We can use if, else, and indif. There are some built-in values that it understands. And you can do dollar substitution. I'll get to that in just a little bit. There are some special variables that control, that are sort of metadata for the route. Target universe is an alternative way of formulating universe. This is basically there for backward compatibility with the old style route syntax. Any grid universe routes will need to have a grid resource. And then the rest of these things are pulled into the sort of route metadata when the route is loaded and used to control the routing itself. So here's an example of a route in the new syntax. The name of this route is going to be area 41 because that's the tag at the end of the knob name. We're going to say that we only want to route jobs that have project blue book already assigned in the job ad. We're going to route them to a Slurm batch system. This particular batch system has a max idle. We're going to set it to change it to 20. There's a default, I believe, of 100. And then we're going to set a couple of attributes into the job ad. And one of the things we've done here is we picked up a knob from the regular Condor config, my router ID, and used it as the value to set into the job. So we're doing dollar substitution like you could in a submit file, but we're doing that in the route at the time the route is applied. Here's an example of pre-route transform. Once again, we have a requirement, so this transform is only going to apply if the job doesn't have an attribute called project. And we're going to use eval set so that the project is set to the string that is the result of evaluating these bits of information, including two job attributes, owner and Q date. This, by the way, could also have been written in this other form where we eval macro into a temp variable, and then we use default to set the project. And as I remember, as I said before, the default command will not change the value of project for a job. It will only set a value if the job doesn't currently have one. All right, so the real power in this new transform language is two things, actually. And I didn't really mention one before, but just to be clear, let's go back and look at this again. When we apply the route, the steps of the route are just applied in the order that they are declared. This is distinct from the old transform language where the route steps were applied in groups by the type of operation, but randomly ordered otherwise. So because we're doing this in sequence now, we can guarantee, for instance, that the eval macro step in this bottom thing happens before the assignment to project. So the other bit of power is this dollar substitution, which we can do to pick up values from the config, from the route or previous pre-route transform steps, or from the job. So let's go into a little bit more detail so you can see kind of how this dollar substitution works, because mastering and understanding the nuances of dollar substitution is going to be necessary to use this, this more powerful route language correctly. So let's say you want to modify the requirements of the job. We can have a route that does set requirements equals, so dollar my requirements, that will expand to the current value of the jobs requirements attribute. And then we're going to tack on another clause after that, and it will be picking up a variable, the variable site from the configuration of the job router itself. So when a job being routed has requirements equals arch x64, once we apply the dollar substitution pass, that will then look like requirements equals arch equals x64, and then site that will then get parsed by the class add parser and turned into an assignment statement. This, by the way, is something, this amending of requirements is something you just can't do in the old job transform syntax. Here's a much more complicated example that involves modifying the job's environment block. Once again, we're going to pick up job attributes, the current value of environment, and also the value of the job attribute y. And we're using a special dollar expansion command sort of thing, $int. If you can see that in that line up at the top. What that actually does is evaluate the expression and then substitute the result of that evaluation. That sort of thing works in config files and submit files, and now in your job transforms as well. So I've used color here to try to help you see where the various bits are coming from. I hope that's clear, although the colors aren't as distinct on my screen as I thought they would be. This new job transform language can be hard to understand, especially with the dollar substitution. And so we have tools that you can use to test things. The job router info tool, or the Condor-CE job router info tool if you're using the CE, can be invoked to print out all of your routes to show you what the configuration looks like, or you can actually invoke it as a testing tool where you pass in a job class add as a file and get out the transformed job class add as a file. You can also use the specialized sort of standalone tool Condor transform adds. You can't use it with the job router config, but if you pull those individual transforms out into separate files, you can pass those files to the Condor transform adds with the -rules argument, and the verbose argument to transform adds will then print out the steps of the transform as they are applied, so you can see what's really going on. All right, that's my talk. Any questions?